Thanks everyone for coming, and welcome to What's Your Strategy? Big Data for Beginners. My name is Vaidi, and I lead product marketing for Tableau in the solution areas of big data, cloud, and advanced analytics, and I work very closely with our technology partners, so companies like AWS and Microsoft and Google and Informatica, and all those great partner technologies that help enhance the value of Tableau to you guys. And I have with me Robin, who is a strategic customer consultant, works very closely with several of you and customers and helping them solve problems. Now, before I start, I know we had advertised this session as a beginner session, but please know that big data is an advanced area in analytics. So this is a beginner talk in an advanced area. We did the same session last year, and the feedback we got was, it was fantastic, but people wanted us to go a couple of clicks down. So we will attempt to do that without necessarily making it hard for beginners to kind of get where we're going, okay? But before we start, just a little bit about ourselves. We'd like to do that at Tableau. So my name, again, is Vaidi, and my motto in life has been to always hustle. I've hustled my way through the data world. I started my career as an analytics practitioner at all these companies, spent many years, even as a Tableau customer even. I started at Tableau in Singapore. I moved halfway across the world to take on a product marketing role to evangelize and articulate the value of Tableau to customers in our APAC theater. And then last year, I moved back to Seattle to take on a new role, focusing on our technology partner ecosystem. And when I'm not hustling, I'm dawdling my time away at the golf course. I love the peace and tranquility that golf provides.
Okay, my name is Robin Cottis, and as you can probably tell from my accent, I'm not from around here. I'm actually from New Jersey. Thank you. Yeah. So you may know New Jersey as that. I actually live in a really nice part of New Jersey. There's a lot of countryside, but that's where I live now. I am originally from England. But I've been in this industry, we can call it BI or analytics or data, for a long time. In fact, I've been in it for over 30 years. But I don't like to talk about that much because that kind of might give you away my age, as does this picture, because I used to be a VAX systems manager, an Oracle DBA in the London Stock Exchange. And that is not me. That guy doesn't look very happy doing what he did. I loved what I did back in the stock exchange days. But believe it or not, that picture is from the product documentation for that system, the VAX 8700, which I was a systems manager for. But I do like to bake bread and pizzas, and I will talk about that anytime. And I actually connected up my brick oven to the internet to collect all the data, and I gave a talk last year on the Internet of Things and data that I collected from the brick oven. When I'm not geeking out on data, I am eating pizzas and bread.
Couple more housekeeping items. You all have an iPhone, and you all have an iPhone app, and that app is your voice. So please, please, please rate the session. Helps us immensely as we design these talks going forward, not just for Tableau Conference, but even when we speak to many more, we're going to talk to customers like you. So regardless of whether you like us or you don't want us back, please rate us. It helps us a ton. And I'm going to call this slide out later as well. Now, I know several of you might also be interested in optimizing the workbooks so they perform well on big data, right? So you're offering dashboards. We're not going to cover that today, but there is another session that is happening on Tuesday. It's by Alan Eldridge. He wrote the white paper that is probably the most downloaded white paper in the history of our company. That white paper has become a talk, super popular, so definitely encourage you to attend that. see. So a couple of leading questions to get us started, just so I could get a pulse of the audience and see who's in the room. Quick show of hands, how many of you are new to Tableau? Fantastic. How many of you are new to big data? Great. And how many of you have or are moving their big data platform to the cloud? Okay. And that's, that actually is exactly what I see in the market. I think it's not it's by no means a representative sample, but it's a reflection of what I see. And I'm sure there's going to be something for all of you today. So here's what we want to achieve. We want to reintroduce big data. The term big data has been thrown around in many different contexts. So we'll take a look at some of those definitions and come up with something that's practical. We'll then evaluate some successful customer strategies and architectures, right? So, one way of doing this presentations would have been just be prescriptive and tell you what needs to be done. We don't believe that. We believe you should all design your deployments, you should architect your deployments based on your use case, and we'll give you some examples of how other customers have done it. Okay, and we'll come up with a way to generalize those patterns into a framework, into a decision framework. And of course, we'll demonstrate that framework with a real example, a real big data set. And then we'll recap with some key takeaways, right? What are some things, what are some mental models that you can take back and apply to your own companies? I think I want to pause this. All right. I think the time is screwing with our... So one thing I didn't talk about is there's also many, many customer talks that are happening this week where how a big data platform was architecture is going to be elaborated in great detail. And I have had a chance, as a product marketer, I get to work with a lot of these customers, and I get to review these presentations. The Ebates and the Netflix ones are absolutely fantastic. I just had a chance to spend some time with the Cisco customer. That's going to be a really good one. Cloudera, we have Tim Hyde over there, one of my friends, and we've done a lot of work with Cloudera. I think it's going to be a great talk. So definitely go check out these sessions, and try to figure out how what you learned here reflects in some of those talks, right? And you'll definitely see those. So let's start with what is big data, right? Different people have defined it different ways. Gartner defines it as data that comes at you at different velocities, that is different volumes, and in diverse formats. The first myth I want to dispel today, and Adam talked about 4 myths. I'm going to dispel another myth today, is that big data is not just about volumes. In fact, there are research studies out there, one by this firm called New Vantage Partners, where they found out that variety, not volume, is the biggest driver of big data investments today. So, and we expect this trend to continue to grow as more and more companies attempt to integrate more unstructured data forms into their systems. And we're talking schema-free JSON to non-flat structures such as Avro and Parquet, and you may have heard these terms, but big data is not just volumes. Here's a more practical definition. I saw this at a customer talk at AWS Summit. AWS is one of our big cloud partners. And in that talk, they defined it as any data that is so large and diverse, and it's a corroboration of the Gartner definition. They're not doing, it's not super different, but it's a little more practical, but because now they've introduced some subjectivity to it. So they're saying we're not going to be absolute because what is big depends on perspective, right? So if you're a small business that has less than 100 employees, even a few million records is probably big for you, right? But if you're an enterprise, you're dealing with billions and trillions of records. So any data that is hard to process, that requires you to innovate, around how you collect, store, and process it is big, right? And what are the challenges that our customers face? Well, they want to analyze these large and diverse data sets on demand, interactively. What does on demand mean? On demand means you want that data to be available for analysis, or you want to analyze that data when you need it, fit for purpose, and you want that data to be available in a format that you can analyze it, right? And we're going to talk about, well, what strategy you should employ with, of course, some customer examples to deal with large and diverse formats of data. So let's just quickly talk about where all this data is coming from. It's coming from logs, sensors, APIs, and it's landing in all these big data platforms. And you know, thanks in large part to you know, the availability of scale-out computation and storage at low cost. Several of these platforms have proliferated, and you may have heard of Hadoop and Spark. And at Tableau, we have invested ahead of the adoption curve, and we believe in the concept of data gravity. We believe our customers should be able to connect to their data where it sits. And across the history of our investments, we have continued to build out connectors to these platforms, right? From all the big Hadoop distributions to the cloud warehouses to NoSQL databases, both on-premise and in the cloud. Just this year, we launched a direct connector to MongoDB and Apache Drill. We are enabling customers to access and analyze data in their Amazon S3 data lakes. Oops. How do I? Give me a moment, guys. I think. How do you fix this autoplay?
It's not. I don't think it's autoplay.
It's doing it. I don't know. All right. So I was talking about all the connectors we've launched. So I talked about Athena, and you may have recently read about Redshift Spectrum. And this is not just restricted to data sources, right? It also extends to all those complementary technology platforms. Several of these companies have actually engineered their products so they work with Tableau. And these include companies like Trifacta and Informatica that allow you to ingest, load, and prep data in the lake. It includes the object stores like Amazon S3 and NoSQL databases, many of which act as data lakes. It also includes several of fast databases and acceleration products that ensure that big data renders fast on Tableau. And it includes catalog solutions, one of which was actually demonstrated in the keynote this morning when the extension API was introduced, Alation. And several of these companies, they use smart, searchable UIs to automate metadata discovery within your big data deployments. But when you put it all together, right, this is what it starts looking like. And I want you to take a pause and, try to figure out or try to imagine what else do you see in real life that looks like this? That, right? It does kind of look like an aisle in your grocery store, right? You have all these options for similar products, not the same, but similar products. And at Tableau, we like to say our customers, and a lot of customers, they tell us that they love choice. They love the choice of being able to deploy Tableau server wherever they want to. They love the choice to be able to connect to data wherever it sits. They love the choice. Soon they'll have the choice to deploy Tableau server on whatever operating system. But sometimes choice can be a bane, especially as someone, if you're in IT, you're trying to figure out what components to use. Well, how do you get started? How do you know which technology is going to be right for you? Which storage option? Which compute option? Even if you've chosen a storage option, even if you've chosen that Amazon S3 is going to be your data lake, what compute option are you going to be using in that, right? So people respond to this paradox of choice a couple of different ways. One way they respond is they go overboard. They will buy every flavor of jam, and that, frankly, is too much work for too little benefit. And this is what might sometimes lead your stakeholders to say, big data is a bottomless pit of IT spend. We don't want that, right? A second way I commonly see customers respond to this paradox of choice is they will do too little. They'll come up with these one-size-fits-all models, right? So, I don't know, just a quick, how many of you have attempted to connect Tableau to Hive, running MapReduce against CSV files on HDFS? I see one hand. It's really not the best option, right? You should probably do some storage optimization, right? Probably Impala on Parquet. That's what you need. But again, there's a lot of options to do it right, and instead of prescribing what the right way of doing it is, what we thought is we should give you what customers have done, right? The answer lies somewhere in the middle, and understanding that middle ground is the key to success. So over the next few slides, what we'll quickly attempt to do is just go over some customer stacks, and the idea is, I'm not gonna go into super detail, but I'll compare and contrast, and I want you to listen for a few key words. I'm gonna be repeating myself. And the goal is, I want you to identify some commonalities, some patterns. What is it that all these successful customers have done? Which, of course, we will include in the general framework we build. So it's a setup for the next session. So let's start with some examples here. Here's GrowPro. This is their big data stack. They analyze streaming log data, right? In this diagram, it splits their platform into a data pipeline and data delivery. And note the use of Parquet on HDFS for storage and Impala as the query engine. Then you have Airbnb. They use HDFS and S3 for storage. They process streaming data. And they use Presto as a querying engine. And they also use a whole bunch of open source and homegrown tools to do analysis. Right? Then you have Grab. For those who haven't heard of Grab, this is Southeast Asia's Uber. Uber is there in Southeast Asia. It's one of the biggest cab-hailing services in Asia. They just landed a ton of funding from SoftBank, huge Amazon shop. They process a lot of streaming data. And note the use of EMR and Spark for data prep, and Redshift and Presto as the querying engine. Right? Then we have Expedia. They use S3 for storage, Redshift as the query engine, and you can see a ton of effort going into the creation of the data prep pipeline. And of course, all of that happens before the data ultimately lands in Redshift and gets consumed in Tableau Online. Here's Edmunds.com. This is the car auction site. They don't talk about where their data comes from, but they talk about the compute and the query layers. They have a serverless and a server-based component. And this data is consumed for self-service analytics in Tableau. And they also have some Databricks, which is being used by their machine learning team. Oops. And then we have Pearson. This is a very interesting use case because it demonstrates all the different sources that data is being ingested from. And note that they have Amazon Redshift as a server-based component and Amazon Athena for ad hoc querying, right? And each of these are being used to service a different use case. Amazon Athena and Tableau extracts form the basis of discovery and ad hoc analyses. But Amazon Redshift, or Tableau on Redshift, forms the basis of the KPI reporting use cases. Right? So they essentially have different stores for different channels through which data has been consumed at Pearson. Pearson, by the way, anyone who ever took the SAT, the GRE, the GMAT, these guys, they're the huge education and media conglomerate. And I think Jason Loxmo, he's one of our customers, he's at this conference. And finally, we have Netflix. Note that a lot of this data is, again, high velocity streaming kind. They're using a fast storage compute for query layer, as well as compute for prep. Amazon S3 is, of course, the data lake where all this information lands. And they're using, in addition to Tableau, a whole bunch of open source tools for analysis. And a lot of this stuff is, by the way, available for public. The Netflix data engineering team is huge. They have YouTube channels, blog posts where they've elaborated the stack and some of the design choices they've made in greater detail. So, do you guys see a pattern? And I'm going to have Robin explain what patterns.
Okay. So you see that when Vahidi went through all of those different and various customer slides, that the architectures had some things in common. We tried to highlight them. But one of the things about the platforms that they have something else in common before I draw the picture. So their big data platform has a common storage layer. It's very often called a data lake, where the data is brought in from all of these various sources. So yes, you can connect to those sources quite often directly with Tableau, and you should, but sometimes when you want to join that data with other sources or productionalize or do some discovery on it at a huge scale, it's worth bringing the data into the big data platform. The server also has what we call server-based and serverless compute engines. The data gets processed through a sort of pipeline as it comes in from the outside, so it's ingested, and it goes through a lot of processing for the preparation and the analytics, and then there can be processing engines for querying to provide fast and scalable queries. As we said right at the beginning, from Vahidi's definition, the Gartner definition, and also the more practical definition is these platforms support both volume, velocity, and variety. It's all three in different combinations, in different times, in different use cases. It's not just about volume. Velocity and variety is very important, and it's usually a combination of all three in everybody's platform. And that they do support multiple use cases. That is the strength of Tableau. It's not just for ad hoc analysis. It's not just for production dashboards or KPIs or production reports. You can use it across the board. And so those platforms also allow the customer to choose the right tool for the job within all of those different components, different layers of the pipeline or stages of the pipeline. And the key thing about the customers that have been successful with this Tableau platform and the big data platform is that they're able to do it in an agile fashion. They can also support governance and security, and they can they'd also take cost into account. Cost is a factor, especially at scale. And so a lot of the different tools allow you to optimize the costs. We did see a lot of different architectures from different customers, and you'll see a lot more this week, I think as Vahidi pointed out, even at TC17. So what I have attempted to do is to summarize all of those different architectures into a fairly high-level diagram, a big block diagram, where we take data in, it gets stored, you can think of that as your data lake, and it gets processed. But I do want to differentiate between the processing for sort of preparation or getting the data ready for a deeper analysis, and the processing for actually getting the data into Tableau, the query engines, the data connections that you're all starting to learn about. For many of you who are new to Tableau, you might be overwhelmed by the number of data connections that we support. And it's one of the things by having this model, we're going to take the fear out of that paradox of choice. Underlying the architecture is not just a vendor stack or a cloud platform like AWS or Google or Azure or Cloudera or Hortonworks or MapR's big data stacks. You have you have your platform. Your platform combines these other platforms, the big data stack platforms, and the analytics platforms, and Tableau platforms. And there are, Vaidi pointed out, a large number of third-party components and platforms in their own right that integrate for the data preparation and the analysis these days. So the machine learning, the data preparation, the government's platforms. For your platform, you will end up integrating them all. All right, so we looked at the customer stacks. I just wanted to go through how the different vendors and cloud platforms draw their stacks and show that they actually do fit into a common view. We can condense all of these different stacks into for purposes of this talk, from the perspective of Tableau, into this big block diagram. Each of the stacks have their own strengths, and you will take advantage of them, but there is some commonality across them all. Okay, so I want to do a short demo of an example use case, if you like, an analytics use case using one of these stacks as a foundation, just to show how Tableau integrates with them. So I want to go on a journey, short journey. I want you to sort of calm down, take a deep breath, think of, oops, we are making it go faster. I was going to say calm down, but we're not going there. We're not going to Myanmar. We're going to New York City. So it's a different type of journey, because the data that I'm going to work with today is a taxi set, a data set that is very popular with a lot of people in the field. It's a public data set for the New York Taxi, from the New York Taxi Commission.
Is it auto playing again?
Yeah, it looks like it is. It's okay.
No, hold on. Let me make a quick fix. I don't know what. I have no idea. It's auto playing all day.
That's okay. Actually, we'll figure it out. Don't worry.
All right.
As long as it goes through the thing. So.
Perfect. All right, go ahead.
New York taxi data is 1.1 billion records in CSV files that you can download from a website. I might have to go fast to keep up with the slides. So we're not going on a journey to Myanmar today, but we're going to take a trip of sorts from raw data to a beautiful Tableau dashboard. Okay. And we're going to use Robin's big data platform. Remember, I said your big data platform. I'll just keep going back if it advances too much.
Does anyone know how to fix this? No. What's it doing?
Don't worry about it.
Yeah. No. I mean, I just want.
It might be me pressing the button.
No. Hold on. Give us a minute, guys. Let's. What was that? Spacebar to pause. Why would it keep doing that? That's a PowerPoint problem, not a Tableau problem. So, all right.
Let's see what happens.
All right.
Is that on pause? I think that's on pause.
It's on pause. Well, I did that. All right, go ahead.
Well, I don't want to play it. Okay, sorry. All right, so we've got a data set that consists of 1.1 billion records, and my data platform is on using AWS, and so we're ingesting the trip data into S3, and we're preparing it, and we're going to cleanse it, and then we're going to access it with several of the data connectors from Tableau, both server and serverless. So this is an example of my big data platform. So we go through various stages. I want you to imagine that my data set I've just downloaded it from the taxi, and I don't know much about the data set. I don't really know what questions I have. I'm kind of interested in the New York taxi data set, but I don't have specific questions, not yet. One of the things that we're going to do is bring it in and do some early cleansing, because this is real data. It's got outliers, it's got erroneous data from the 7 years worth of data over the 1.1 billion records. They're not all perfect, so it does need some cleansing. And it can also do some preparation. We can also do some preparation to make the querying of that data fast, even for discovery. So what I did was I brought this data into EMR, which is the AWS Hadoop stack, and I then just connected to it live. Okay, let's run the video. Let's see. Here we go. So I'm going to connect to it live, and we're going to just take a look at this data. So remember, it's 1.1 billion records, and it's... Is it running? No, okay.
It's running.
That was the other one. Oh, that one's running. There we go. Yeah, sorry. So we connect to Presto. This is the Tableau Presto connector. Presto was an open source connector developed by Facebook. It's supported by Teradata. But it is going ahead.
I think it might be the clicker. I have no idea what's going on. Can you help us a little here? Let's see. I think it might be the clicker. Let's try mine.
Let me see. Well, let's leave it on pause and then see what happens.
Yeah.
Well, that's got timing. That is got timing. I don't want it to run that. No, it's running ahead.
It's running ahead still?
Yeah.
Why?
What was the clip?
I have no idea.
Sorry, thanks.
Sorry, man. What was that?
Try F to freeze.
F to freeze? Okay.
It's PowerPoint, right?
Yeah.
It is PowerPoint. Yeah, there's really nothing to it.
That's weird.
I know. I'm going to turn all of the stuff on.
I don't know if we can do that. Okay, well, we might be able to do that. Let's see what happens when you do that. All right, present. Okay, we're showing the screen. Can I go ahead now? Yeah, let's see if this goes ahead. Sorry. If it doesn't jump ahead, we're good. If it gets past this stage, we start connecting to the data. Yeah, so we're connecting to raw 1.1 billion records of data, but it's not just in raw CSV at this stage. It's being compressed and turned into a columnar format on S3 called Parquet. So it's a bit more optimized for live connection from Tableau. And we're going to bring in the taxi data trips. We're going to join it to some dimension data, in this case, just time dimension, so that we can look at the data by dates and years. The data itself has got a timestamp. It's not just daily data. There are upwards of 500 trips per day in this data set. So as you can see, I'm just bringing it into Tableau, and cleaning it up a little bit in Tableau, and then we can go and take a quick look. Before even the data is fully cleansed and fully joined, we're going to get a quick look. So this is early on. I'm sort of in discovery mode. I'm looking to see what the data is even about. And so I want to look at just 1 day's worth of data from the billion records. But it's going live against our S3 using EMR and Presto. The data has geospatial data. It has the latitude and longitude of the pickup, and I just disaggregated it. Okay, I think we're just going to have to go to the next one. Okay, we'll just go to the next one. But that data allowed me to see it. We'll fix that.
What happened there?
We went on. Hold on, we're going. I don't know where we're going now. Okay. So, what slide are we on? one.
Slide number was this one, right?
Yeah, just go on here.
Okay.
Is it playing?
Yeah, you're still on the video over there.
Yeah, we want to be on that slide. Are we presenting? Oh, resume slideshow.
Yeah.
Okay, sorry, having some problems here. So what I wanted to do now, once I saw that data in Presto, I realized that it would be very nice to see the data joined with a shapefile that tells us about the zones and the boroughs in New York City. And we can actually bring that in. It's not advancing.
What's that? What happened?
Oh.
Okay.
Sorry. I'm jumping ahead, sorry. Okay, so we have data in a zone, a shapefile. It's a spatial file that Tableau supports. And I want to bring in that data and take a look at that directly in Tableau, even before it makes it into the data lake. Oh no, it's not.
Is it jumping ahead?
Yeah, it's jumping ahead. We'll have to do without the Tableau slides. We'll just stick on the slides. I don't know why it's playing.
You sure?
Yeah. Let me just go through the stages, otherwise we'll run out of time.
Okay.
We will be doing this session later on. We might have fixed it then. But
Yeah,
okay,
we'll probably fix it by then. Yeah.
So I did join the data to some spatial data. Then I wanted to summarize that data and join it to the detailed data. So that we've got 1.1 billion records of taxi data, and then we've got a shapefile that describes the latitude and longitudes of the spatial data in terms of zones and boroughs. And I used a Python script to prepare that data, so that's the sort of thing you do in your data for prep platform or compute layer. And then we can summarize that. So I don't know whether the video is going to work, but at least you can see here that we've actually combined the zone data with the trip data, or the summarized or the pickup points for this taxi trip data. And so there are several thousand trips that we can see, and we're just joining those two in Tableau. So again, you're connecting to multiple data sources in Tableau. It might jump ahead. We might see if we see any of the data that we bring in after joining it to the timing, joining it to the taxi data, the zone data. Hopefully we get that far. There we go. Oh, it did go on. So our final view is if we get questions at the end, I may be able to get some of these demos. Our final view is I took this data and we combined it all together to build a dashboard on Tableau server, which can be shared with thousands of people, a lot of our other friends and family. We can actually share this and have a very high-performant dashboard that allows you to select off a scatter plot like that and then go live against our big data platform. In this case, it's Redshift and Spectrum to drill down and get more detail. And so this is where you can combine the different compute engines with the different query engines in Tableau to provide a seamless experience for your end user, but it'd be highly performant and very cost effective.
A wild ride.
So that was a wild ride. I didn't intend it to be that wild, sorry. But you get the idea that we're using multiple data sources, multiple connections in Tableau.
We try to be too cute with PowerPoint.
To build a, maybe we did, to build a whole end-to-end use case. Now, any one use case that you have might not use all of these components, but they certainly will, all of your use cases could well use several of these components. And just let's recap what I did do. So we did look at raw data from our CSV file in Tableau. We looked at raw spatial data in Tableau to get an idea of the data space, if you like. Then we cleansed some of our data into Parquet and S3 and EMR to be able to get a live connection, even in discovery mode, very quickly into our analytics process. And then we created I looked at a summary of the data with the data zones and mapped it, and then we connected to, we left our data in S3. The data didn't move, but we used Redshift and the Redshift Spectrum as a compute for query engine to get the data out for our production dashboard. And so this is a sort of end-to-end life cycle of an analysis that might take you from ad hoc discovery to a production dashboard. Okay. So all of that choice might be quite daunting, but what I wanted to get across was that choice shouldn't be daunting if you know why you're using the different, compute for query engines or the different processing engines inside your big data platform and then connecting to them for Tableau. And this comes from a real experience that I had of recently going to choose, and buy a pair of jeans. Now, it's not that hard these days to, people might disagree, it might not be, I don't think it's that hard to buy a pair of jeans if you know what you're looking for. Now, it's obvious that you're going to need the right size, and that's fairly easy to get. But in today's, jean marketplace, you've got a lot of choice in terms of color and style, and or a lot of other, components that go to make up, a pair of jeans. And so I wanted to sort of draw a parallel between choosing, buying jeans and how you go about it, and choosing data connectors, so that the choice that you have is not so daunting. And so we can look at our compute for query engines, or from the Tableau side, connection, data sources, the drivers that you might use from Tableau desktop or Tableau server to connect to the database, and look at some of the factors that influence how you might choose a driver. Some of the obvious ones are performance. So this is the size, it's pretty obvious, although there are other factors for performance, and one of them is latency, and that is how quickly can you start get the data back from your compute engine, from your data source to Tableau. So that depends not just on the amount of horsepower or the amount of cores or compute components. It also matters about the query engine, how fast it can deliver the data back, how fast it can resolve the query, which Tableau is actually sending a SQL query, when you're dragging and dropping. And some of the data engine compute for query engines have what we call you want a low latency to have very fast queries. So Impala is a low latency query engine. As an example, and there's another perspective of latency, and that is, well, how long does it take before you can actually get access to the data? Does it need your data, big data team to prepare the data to get it into that format? And so it's a balance of different performance and latencies. So that's obviously compares to the size of a pair of jeans. You can make different choices there. But the other factor, and we talked about it being ad hoc versus production dashboards, is where are you in your analysis life cycle? At what point are you just starting to discover? Are you in a sandbox? Are you doing ad hoc? Or are you building a production KPI metrics that's shared with external customers and needs to be highly performant, highly available, but also secure and authenticated, and do things like row-level security. So that point that you're at in your life cycle could influence the data connection that you choose. And obviously I mentioned security. Security is a factor increasingly because of the variety of use cases that Tableau is being put to use. A lot of those use cases require governance. Again, as Adam mentioned this morning in the keynote, it's a myth that the governance means no. Governance means enabling you and your customers and your users to be able to get access. But we want to be able to help you do it securely and safely. And then there's cost. So the security, by the way, if you're still tracking along, like how does that compare to buying a pair of jeans? And I was thinking, well, one of the features of a pair of jeans might be how many holes are going to be in the pair of jeans that you're buying. I mean, I don't like holes in my jeans, but we can equate sort of holes with security, if you like. And maybe point and life analysis might be the style and or the color. And then cost, well, that's cost. It's very easy to think about the comparison there. But cost is a factor in building a mission-critical or a large-scale analytics application, or a use case. If you're scaling it out to 20,000 users, cost is a factor, and it will be. It always is. And how you choose and how you optimize your data connections is very important. Okay, so we're going to do some
great
takeaways.
Okay.
And I will hand it back to Vaidi.
Yep. So let's just recap what is it that we did, right? We looked at some customer examples. We generalized their design choices into a framework that hopefully will give you a mental model to go apply to your own stacks. But before we end, I just want to recap some key takeaways, some things that you could remember as you go about architecting your own big data deployments. So the first is embrace continuous improvement. Can you see that? No, good. Well, what do I mean by embracing continuous improvement? Well, it means that you should promote ad hoc analyses within your organization and use the guidance to automate what can be automated. So to give you an example, let's say the analysis that Robin did of looking at New York City taxi data and coming up with a few insights. If we all agree that that analysis has long-term usefulness, you can always automate the pipeline, and that way you're matching the speed of the analysis to the speed of decision making. That way you don't have to wait until the next data element comes in. It is all processed, ready for consumption, and ready for use. The second is design and redesign as your needs evolve. Several of our biggest customers, they will change their stack every other year. They don't design architectures with a 10-year shelf life because your data is going to grow. You will have 10 times more data in the next couple of years or your data will grow a lot faster in the next couple of years than it did the previous 2 years. And every time your data grows and you start ingesting newer formats, that presents an opportunity to innovate around how you store and collect that data. Second, you got to consider the breadth and depth of use cases because data today is multi-channel. Well, what do I mean? Again, think about what Pearson did. Oops. I think we're going to have to do it the traditional way. And now our slides are stuck.
No, we can get rid of that one. So
what happened there?
It's on the resume slideshow.
Yeah.
There we go.
Nope. That doesn't do it either.
I don't know, you're going into the slideshow pause.
All right, perfect. So consider the breadth and depth of use cases. Design your architecture for the use case, not for perfection, right? So in every organization, there's a department that is doing ad hoc analysis, but there's also a set of users who are answering questions, the same question that gets asked daily. So how much sales do I have against quota? Or how many widgets of a certain type have I sold in a certain county in the last 2 years? It's the exact same question that gets asked every year, right? That is very different from a machine learner or a data scientist trying to scour a billion products across the last 10 years for some exploration, right? So 2 different use cases, but you have to optimize for both of those when you design architectures. Also, be aware that data today is multi-layer. So you'll have multiple platforms within a platform. The Tableau platform is a constituent of the big data platform, and there's multiple ways of integrating them. And it's multi-sourced. The same data element could be sourced from multiple places. So a great example is, well, I worked in manufacturing for a few years. Let's say I'm a field engineer. I'm at a customer site trying to repair a piece of industrial equipment. This could be a gas turbine or a wind farm. Now, this gas turbine has some sensors embedded in it, and it is transmitting data over the air to your big data platform of choice. But once the field engineer goes on site, he'll also recover a hard drive with the latest and greatest information. So 2 separate places where this data lands, but it represents the exact same thing, right? So again, just alluding to what Adam mentioned earlier today, single version of truth is just so old school. These days we have point-in-time truth, and we have multiple versions of the same truth, right? And it all depends on what context that truth rests under. Learn from the community, right? There's incredible amounts of innovation happening in the Apache Foundation. There's new execution engines, new ways of optimizing and optimizing data and making data fast that are happening every day. So you should continue to explore these components, stand them up, test them, and that's the way to continue to innovate around how you're architecting your stack. And as big data engineers, many of us, we love playing with new tools. And the last and the most important takeaway, I would say, if it comes up, it didn't, so I'll just say it. One size doesn't always fit all, right? You should always create your stored data create stored data for analysis, and again, what that means is optimize how your data is stored and optimize how your data is made ready for analysis before you start analyzing it, right? Just because your data lands in S3 or lands in a data lake doesn't mean you should always connect directly to that. It'll probably have to be provisioned in some structured format in Impala or in Redshift before it's ready for KPI reporting use cases. But if you want ad hoc analytics, absolutely directly connect to S3, right? So be mindful of these things, and thanks all for coming in. And really apologize for the PowerPoint troubles. I think we're going to fix those before we do the same session in a couple of hours. But again, please rate us and have a great rest of the conference. Thank you so much.
Yeah, thank you.